Hey guys, Mr. Milton here. Today we're looking at Pythagorean theorem and its converse. At the end of this video, you should be able to find the lengths of using our side lengths using the Pythagorean theorem, and you should be able to classify triangles using Pythagorean theorem. Okay, so recall, Pythagorean theorem is a squared plus b squared equals c squared. We've used it a couple times even in this chapter. Okay, so you guys should be familiar with that. So here it says a right triangle has side lengths 4 feet and 8 feet. Find the length of the hypotenuse. Give your answer in simplest radical form and round it to the nearest tenth. So we have a right triangle here. This is 4. This is 8. Okay, so a squared plus b squared equals c squared. Okay, and so that's 16 plus 64. C squared is 80. So two ways we can do this: simplest radical form. Remember, that's just taking your pairs. Looks like it's going to be like 16 times 5. Okay, 5 is prime, 4, 4. That's a pair. Okay, so we have 4 radical 5. Okay, if you wanted to, you could just take the square root of 80 in your calculator if they ask you to the nearest tenth or something like that. In your calculator, square root of 80 gives you 8.94. So 8.9. Okay. So Pythagorean triple is a set of 3 numbers that represents the side lengths of a right triangle. To see if a set of numbers is a Pythagorean triple, you plug them into the Pythagorean theorem. Okay, and if it works, then it's a Pythagorean triple. If it doesn't, it's not. Okay, so 8 squared plus 16 squared equals 24 squared. Important that you remember that the longest side has to be the hypotenuse. Okay, so 8 squared plus 16 squared equals 320. Pretty sure that that's not going to be the square root of 24. Square root of 24, or sorry, 24 squared equals 576. Okay, so they're not equal to each other. So no, this isn't a Pythagorean triple. Okay, here we have 6, 12, and 6 radical 3. A couple things, making sure that you remember that you have to have the hypotenuse be by itself. So if you're in any kind of confusion of which is bigger, 12 or 6 radical 3, make sure that you're figuring that out, and you can just do that in your calculator if you like. 6 radical 3 comes out to be like 10.3. Okay, so as we set this up, we want to have 6 squared plus 6 radical 3 squared equals 12 squared. Okay, so 6 squared, 36. That's what, 108, right? Yep, 108 equals 144. There we go. So 144 equals 144. It works out. Yes, that is Pythagorean triple. Okay. All right. If a set of numbers does not form a Pythagorean triple, we can classify the triangle by its angles. Okay. And this is how you can think about it. If C is larger, then the triangle is an obtuse triangle. And if C is smaller than a squared plus b squared, then it will be an acute triangle. So as we look at this triangle in our first example, 8, 16, 24, we see that c squared is 576, where a squared plus b squared was 320. So this would be an obtuse triangle. No, they didn't ask us that at the time, but just wanted to give you an example since we've already done one. Okay, so here we go. A couple more examples. It says, classify the triangle by its angles with side lengths 4, 6, and 7. So as we set this up, 4 squared plus 6 squared equals 7 squared. 16 plus 36 equals 49. 52, 49. Okay. So not a right triangle, not equal, but here we see that a squared and b squared are greater. Okay, and so that makes this an acute triangle. Okay, looking here. Maybe I shouldn't have the equal sign there. Okay. 8, 17, 15, just making sure that you're paying attention to actually set it up so that our two shorter sides are together and our longer sides by itself. So 64 plus 225. What is that? 289. Yep. Okay, and so we get 289 equals 289. Now, because it's the same, it is a right triangle. Okay. All right, a couple more problems here. It says a baseball diamond is actually a square with 90 feet sides. How far to the nearest foot does the catcher have to throw the baseball if he's throwing from home plate to second base? So as we look at this, baseball diamond, square with 90 feet, Yeah, okay. So catcher would be here, second base, like this is first, this is second, this is third, okay. All right, so they're asking how far does the catcher have to throw? Basically, what is this length? Okay, so as we look at this, this is 90, this is 90. All right, so we can find this, well, a couple different ways. I can kind of see that this is an isosceles right triangle. Okay, and so we'll just use Pythagorean theorem though. 90 squared plus 90 squared equals, I'll just call this x squared. Okay, so that's, I'll do that in my calculator. 90 squared plus 90 squared gives us 100 or 16,200. Take the square root of that, and that gives us 127.3. All right, to the nearest foot, 127 feet. Okay. Number 2 says find the area of the triangle below. Okay, remember that area of a triangle is 1/2 base times height. Okay, our base in this case is 40. We don't know the height yet. Okay, but we can find the height. And I guess that's the point of this problem. Okay, here they give us that this is an isosceles triangle, right? These base angles are the same. Okay, and this is a perpendicular bisector, has to be, right? And so what that does is it splits this side into 2. So if this is 40, then this is 20. We need this in order to be able to use our Pythagorean theorem. So we have 29 squared equals 20 squared plus h squared. That's 841. 400 plus h squared, so 441 equals h squared. All right, subtracting 400 from both sides. All right, so the square root of 441 is 21. So we find out that our height is 21. And so now area equals 1/2 our base, which is 40, right? Because it's still the base of the entire thing, 40, times our height, which is 21. So 20 times 21, and that gives us 420. And I'm just going to say units squared. Okay. All right, number 3 says find the lengths of the indicated sides in the area, or if the area of triangle ABC is 24 feet squared. Okay, give your answers in the simplest radical form. Then classify triangle ABC by its angles. Okay, so it tells us that ABC. So the area of this triangle is 24 feet squared. Okay, so area equals 1/2 base times height. Here we're given that our base for this triangle is 12. Right, 4 plus 8 is 12. Okay. We know that the height, because they told us, is 24, or sorry, the area, because they told us is 24. So we can find the height here. Okay, so 1/2 times 12 is 6. So 6/8 equals 24. That must mean that h is 4. So our height here is 4. It's BD. I'll just call this point D. Okay, so the height's 4. And so now I'm trying to find out what my hypotenuse is. Okay, I have a right triangle that's an isosceles right triangle. So I'm not going to spend a whole lot of time on AB because isosceles right triangle, this must be a 45, 45, 90 triangle. Okay, and so this must be 4 radical 2. Okay, and so AB is 4 radical 2. Okay, even if I did Pythagorean's theorem and did 16 plus 16 square root of 32, that would give me 4 radical 2. All right. So now I'm trying to find BC. Again, I have the height, I have the base. This isn't a special right triangle, but I'll set this up here to find BC as, call this X. A squared plus B squared equals X squared. 16 plus 64 equals X squared. That's 8 equals X squared, square root. And that is 16 times 5, 4 and 4, 4 radical 5. So we find out that X is 4 radical 5. Okay, all right. So now they're asking us about classifying triangle ABC. Remember that we can do that by using our Pythagorean theorem. Okay, and in this triangle, just redraw it really quick here. This is 12, this is 4 radical 2, and this is 4 radical 5. So as we set it up, we want to make sure that we know what the longest side is. I think it's pretty apparent that our longest side is here. We can think of that. Is any of these going to be 3? Radical 5 has to be less than 3. Radical 2 is less than 3. Okay. All right. So as we set this up, 4 radical 2 squared plus 4 radical 5 squared equals 12 squared. All right. So as we multiply this, that gives me 16 times 2, and that gives me 32. 16 times 5, and that gives me 80. 12 squared is 144, so that gives me 112. And we see that 144 is greater than 112, so this is an obtuse triangle. All right, so there we have it. Pythagorean theorem and its converse. All right, see ya.